Hey everyone, what is going on? Welcome to Focus AI. So this is the very first tutorial of K nearest neighbors, also known as KNN. So here I will give you a visual intuition, or maybe you can say a geometric intuition, by which we will try to understand KNN, how KNN usually works in a classification type of problem. I mean, which will be similar to regression type of problems, but here we will be focusing more on classification. So now, as I have mentioned in my previous video, like for a classification or maybe for any machine learning problem, we need a data set DI. So this is our data set DI, which is denoted geometrically in a high dimensional space. But considering here, it is a two-dimensional space because I mean, we human beings cannot draw anything in a high dimensional space. So high dimensional space means, or a two-dimensional space means, these are the points which are nothing but the feature vectors of having R of 2, that is R of two-dimensional, real numbers of two-dimensional vector. Okay, so here I am considering there are two classes. We are doing classification, so there should be some classes or some labels. So here we are considering two classes. So the star here actually denotes the positive class and the plus here denotes the negative class. I'll come to this query point. What is it? Now, if we plot the feature vector from from this data set di, say we plot it and we got us this kind of plotting in a two-dimensional vector space. Okay, now you can see like there are almost like you can see like this yellow pluses are in a similar space and these blue stars are similar space, and obviously I intentionally gave one yellow plus in this blue star cluster and a blue star in this yellow star cluster or yellow plus cluster. So because I have introduced error, because real life data set, to be honest, is very much noisy. There are techniques by which you can clear out the noise. There are techniques. I will go through all of those techniques. But for the time being, just understand that there are noise. So here you can see there is a noise, and here also a noise. Now our target is that for a new point, which we call a query point. So for a query point, we have to find out that this point belongs to which classes. Is it belonging to the positive class or is it belonging to the negative class? So how does this KNN works? Now say this is the position, or this is like the, yes, the position of the query point. Now what does KNN do? It's actually verifies, or it actually calculates the nearest neighbors. So how many nearest neighbors? That is k. So here I am considering k as 3. Now considering k as 3, I am calculating this circle and I am getting 3 nearest neighbors. This is the first one, this is the second one, and this is the third one. Once these neighbors are found out, then we do a simple majority vote. So what does it mean? That for this query point or for this green point, we found three neighbor points, and we will check what are the class levels of those neighbor points, and we will do a simple majority vote. So here in this case, we can see that all the three neighbor points are negative class, right? This plus belongs to negative class. So we can predict, or the KNN can predict that, okay, this particular query point will be a negative class because it's all the neighbors were negative, or the majority of the neighbors were negative. Now it might happen that a star might come here, and still we, I mean, the negative class will win because of the majority vote. Okay, so this is how k nearest neighbor works. Now this is a geometric intuition just to visually understand you that how KNN works. Now I think you have a question like, how does it calculates the distance, or what is the distance? When you are saying that, okay, it's measuring the distance, and obviously the neighbors are those distance which are really close to the query point. Yes, obviously there are some distance which are being calculated. So we have to carefully go through that, what are the distance, what are the merits of each of the distance, what are the demerits of each of the distance. So I'll go through in all the distance thoroughly in the next video. But this is to give you a geometric intuition that how KNN works. Now there is one important concept that I need to cover. This is called the concept of hyperparameter. So by the name you can guess like this is not an ordinary parameter. This is something like a unique parameter which is named as hyperparameter. So in simple term, hyperparameter is a type of parameter attached to any machine learning model that can affect the model performance if the parameter value is changed from one value to another value. Okay. So in KNN, the parameter value is k, which is the number of nearest neighbors we should calculate. Right. In our example, what we did, in our example, we calculated the nearest neighbor by considering k equals to 3. Now here the k might be 5, right? Then we'll consider another 2. So total of 5, and we will do the majority vote. We can take k as 7, we can take k as 9, we can take k as 13, 11, 15, whatever it is. But one best practice is that for KNN, try to choose odd numbers as the value of k. That is 3, 5, 11, 13, 15, 17, like that. Why I am saying that? Because KNN gives you the prediction based on majority vote, which is the main thing for KNN. It gives you results on majority votes. So say if you are taking the value of k as 4, right? And you got four nearest neighbors. Now, two are positive class and two are negative class. Out of four neighbors, two neighbors are from positive class and two neighbors are from negative class. Then what you should, I mean, what the model should give you as a predicted class? You never know. Then it would choose randomly either of the class and it will give you the prediction. So the performance will degrade. So always remember, try to choose odd numbers as the value of k. Okay, so in the next video, we will discuss about how the distance is calculated to capture the nearest neighbors. Okay, so there are many distances like Euclidean distance, Hamming distance, Minkowski distance. So we'll cover all those distance in details, and we will say like which distance to use, what are the good points of each of the distance, when to use each distance. So I will cover all those things in the next video. So till then, have a good day and happy machine learning. Thank you.